All right, we're writing balanced chemical equations from chemical names. On page 3 of the chapter handout, we're looking at letter A. Carbon monoxide gas, that is CO with a little g. It reacts with oxygen gas. You're going to write plus. Oxygen is supposed to be highlighted on the periodic table because it is a diatomic element, so you have to write a subscript 2 after it when it's pure. You're producing carbon dioxide gas, so we write an arrow and then we put CO2 with a little g after it. Now, we have to balance it. I have 1 carbon on each side of the arrow. I have 2 oxygen here, 2 oxygen here, but I have an odd number here. What have I told you about balancing when you have an odd number of something? It is typically easier if you make it even. So what I'm going to do is put a 2 in front of CO because I can distribute that 2 to the C and the O. When I do that, I need to put a 2 in front of CO2 to balance my carbon. Now I have 2 on each side of the arrow. If I look at the oxygen that I have on the left, I have 2 oxygen here plus 2 oxygen here, which is 4. And on the right, if I multiply these 2, I get 4. So I have 4 oxygen on each side. You can either leave the blank in front of the O2 or you can put a 1 there, and this is letter A. Letter B, solid tin 4 oxide. For this, you have to cross charges. These are the 2 ions that you have. If you cross their charges, you're going to end up with SN2O4. Now, you can simplify the subscripts and make them SNO2. It's a solid, so we put a little S after it. It's combining with solid carbon. Carbon is not highlighted on the periodic table. That means it is not a diatomic element, so I am not going to put a subscript 2 after it. It's producing tin and carbon monoxide gas. Tin is SN, carbon monoxide is CO. So here is your equation, but we still have to balance it. I have 1 tin on each side. I've got 1 carbon here and 1 carbon here, but I have 2 oxygen here and 2 oxygen here. So I'm going to put a 2 in front of CO to balance the oxygen. Remember, this gets distributed to the elements that are after it in the compound. So I've got 2 carbon, so I'm going to put a 2 here in front of the carbon. I have 2 oxygen, 1 tin, and 1 tin. So we're going to put 1s in the blanks, and there you go. Now you're balanced. The next one is C. It's sulfuric acid, which is an oxy acid. All acids contain hydrogen. Sulfuric means you had the sulfate ion. You have to cross those charges to get sulfuric acid. It's going to be H2SO4. All acids are dissolved in water, so we're going to put an AQ after it. Sulfuric acid in a solution of aluminum hydroxide. So we're going to put plus, and then aluminum is Al plus 3. Hydroxide is OH minus 1. We have to cross the charges. You're going to end up with Al parentheses OH parentheses 3. Since this is a solution, you have to put AQ after it. You're forming aluminum sulfate and water. Aluminum sulfate is Al plus 3 SO4 minus 2. Cross the charges. You're going to get Al2 SO4 3 plus H2O. So it looks like this, okay? You have polyatomic ions in this equation, which means you will balance them as groups. So you're going to balance this SO4 with this SO4, and you're going to balance this aluminum with this aluminum. This hydrogen is going to get balanced with the hydrogen that's listed first here. I rewrote water as HOH because I'm going to balance it as hydrogen attached to hydroxide. Here is my hydrogen, here is my hydroxide. Okay? When you have water on one side with a hydrogen in a compound and a hydroxide in the other compound, you may rewrite water as HOH. Okay, so I'm balancing the hydroxide over here with the hydroxide over here. So I'm going to first look at the aluminum. I have 2 aluminum here, so I'm going to put a 2 in front of AlOH3. Okay. Now my aluminums are done. Multiply that 2 by that 3. You're going to get 6 hydroxides. So you want to put a 6 in front of HOH. You've got 6 hydrogen and 6 hydroxide. Okay? So we're going to put a 3 in front of H2SO4 because 3 times 2 is 6 hydrogen. I have 3 SO4s here, 3 SO4s here. We're balanced, and that's it. We're done. The last one is liquid octane, a component of gasoline, which is C8H18. Combusts by combining with gaseous oxygen. Oxygen is highlighted on the periodic table. It's diatomic, so we have to write O2. It forms gaseous carbon dioxide and gaseous water. So it looks like this. Okay. All right, so you have 8 carbon over here, so we're going to put an 8 in front of the CO2 to balance it. You have 18 hydrogen here, so we're going to put a 9 in front of the H2O because 9 times 2 is 18 hydrogen. Count the number of oxygen you have on the right-hand side only. 8 times 2 is 16 plus the 9 you have here. 16 plus 9 is 25 oxygen. That's an odd number of oxygen. Remember I told you if you have an odd number of oxygen, you have O2 on the other side. Then what you want to do is put the odd number that you want here with the O2. You always balance the O2 last. And what you do with the rest of the coefficients is you double them. So this 1 becomes a 2, this 8 becomes a 16, this 9 becomes an 18. So it's 2, 25, 16, 18. You do this with combustion reactions, which are a hydrocarbon, which is predominantly carbon and hydrogen. It's combining with pure oxygen, which is O2. You always make carbon dioxide and water. When you have an odd number of oxygen on this side, you put the odd number that you want here, and you double the rest of the coefficients. Okay, so now you're ready for writing balanced equations from chemical names. And just take it slow. You'll need your periodic table.